Today we'll be looking at the ground penetrating radar, GPR for short. It is a cheap, relatively easy to use, shallow geophysical method. It is often used at geotechnical sites, such as building locations, to map the location of underground features such as pipes. Okay, let us look at the equipment to put together the ground penetrating radar. Firstly, we have 4 wheels that need to be connected onto the machine. We need to make sure that the pins of the wheels basically align with the holes or the grooves that are in the machine. Next, we're going to put in the mast. This will essentially drive the GPR, like the steering wheel. And we just need to clip it in there at the bottom to make sure that it is secure. Let us adjust the stand on which the console will be resting upon. Here's the console here. So there are holes at the bottom of the console. We need to make sure that these holes align with the pins that are on the stand, and essentially clip it in. Next, let us open up the box so that we can attach the digital antenna onto the console and essentially groove that into the receiver port onto the console. Next, let us close the lid. Let's just make sure that the GSSI logo is facing the front. Next, let us adjust the straps. Make sure that the machine is not too low on the ground, but also not too high. Perhaps just an inch would be just perfect. Lastly, let us put the battery into the console. Clip it into the slot provided. And essentially, we are done. Firstly, let us power on the console. So there's a green button here for power on. And this is the screen that it displays. So you have a control knob, which is what I'm twisting here. There are 2 modes that it gives us for the digital antenna. We have 2D and we have 3D. So down here, this is the control knob, which is what I'm using. Then you have the directional keypad. Then you have your start and your stop button together with your back arrow. And lastly, this to mark points on your data. At the bottom here is the control panel. And you can select different settings, such as to fix the antenna, the language settings, etc. So we are running a 2D line. So we're running 2D mode. Let us start a new project and name it Lesra. So this is what it initially shows you. On the vertical side, you have your depth in meters. On the horizontal side, you have the distance at the top in meters. And here you have the oscope that shows the wiggle of your data. So there are different things that are available here. You have radar, process, output, and system. There are already default settings that are set inside, but however, we can edit some details. So there's collect mode, which can either be in distance, time, and point. We'll leave it at distance. You have other things here which you can leave in default. Okay, so what's important here to note is that your dielectric, which needs to be properly set according to the material you are surveying. So the default is usually 5. We can leave it at that. It is the dielectric for granite, which is the material that we are standing on right now. So I'll just edit here and shift it from 20 to 5. Okay, so we can see the depth here that it goes up to approximately 9 meters once I've changed the dielectric. Can exit that and go into process. There is nothing here to really change. The gain mode can either be automatic or set at manual. We will leave it at auto. You can also turn the signal floor, which is this green overlay, on or off. It basically shows your attenuation, which is the loss of signal with noise. So anything below this depth, you won't really be able to see proper reflectors but noise. Next, we'll go to output. So we can leave most settings here in default. The vertical scale is in depth. We'll leave it at depth in meters. And there's the O-scope, which you can turn on or off. We'll just leave it on. And we can exit. Lastly, we have system. You have things such as brightness and volume, which we'll leave as is. The most important thing here is to calibrate the survey wheel before you begin your survey. There's also a GPS, but we don't have one inserted in here. We can look at how to calibrate our survey wheel now. So let us calibrate our survey wheel. So you need to do this when putting on new wheels or changing the terrain on which you are doing your survey. Option given is quadrature, which is for 4 wheels, like we have in our system here. 10 meters is the default distance that is often given. So we'll leave it at 10 meters. What you need to do is measure out 10 meters on your ground surface, then press start to begin walking out your 10 meters with the GPR. Once you are done, press stop and save. This has already been set, so leave it as is and exit. So press cancel instead of apply. And we are now ready for our survey and need to short press the start button. Let us begin our survey. We'll short press the start button and start moving along. Make sure that you have previously marked out a 2D line that is straight. And walk gradually, not too fast, not too slow. Once we have reached the end of our survey line, we are going to short press the start button or long press the stop button, and it will automatically save. Okay, so this is what our screen looks like at the end. That is the distance traveled. This is the maximum depth. We cannot really see anything, so let us edit our gain. If you put a gain that is too high, it obscures the data. So we're going to put it at 8. You can either zoom in or zoom out. The dielectric here is set at 5. And we can either turn on or off our hyperbola. There are no hyperbolas in the data, however. So this would conclude the end of our survey. This concludes today's video on the ground penetrating radar.